You open your eyes. Everything is moving, not you. You are still, but everything around you is in motion. Slow, silent, unhurried motion. Pieces of ice drifting past at different speeds. Some the size of your fist. Some the size of a car. Some so large that when they pass between you and the distant sun, they cast a shadow over you that lasts several seconds. You are inside Saturn's rings. You look to the left. The rings extend outward in that direction as far as you can see. They are not what you imagine from the pictures taken far away. They are not a solid disk. They are individual pieces. Millions and millions of individual pieces of ice and rock, each one on its own orbit, each one moving at its own speed. The whole collection so dense in some places that you cannot see through it, and so thin in others that you can see the stars on the other side. You look to the right, the same, the rings stretching away forever. You look down, and there is Saturn. Below you, filling the lower half of your entire field of view, the planet itself, pale gold and cream, faint bands in the atmosphere like a quieter version of Jupiter. The whole enormous sphere, hanging below you so close that it feels less like a planet and more like a floor. A very beautiful, very distant, very deadly floor. You are in the rings of Saturn, the most beautiful place in the solar system. You are going to die here. But not yet. First, the rings. Saturn is the jewel of the solar system. Every other planet, when you describe it by what it does to you. Mercury burns, Venus crushes, Mars deceives, Jupiter swallows. But Saturn you describe by how it looks. Because nothing in the solar system looks like Saturn. The rings visible from Earth through even a small telescope, the wide flat disk tilted at an angle, the planet glowing inside it like something placed there deliberately. Every astronomer who has turned a telescope towards Saturn for the first time has had the same reaction: disbelief, the feeling that it cannot be real. It is real. The rings are made of water ice, mostly, pieces ranging from the size of a grain of sand to the size of a house, each piece on its own orbit around Saturn. The whole system, 300,000 kilometers wide, and in most places only 10 to 100 meters thick. If you compress the rings to the same scale as a sheet of paper, they would be thinner than the paper. They appear solid from far away. Up close, they are a crowd. A very large, very cold, very slow crowd. The rings are all too temporary. On the time scale of the solar system, Saturn's rings are young. They formed perhaps 100 million years ago, possibly from a moon that came too close and was pulled apart by Saturn's gravity. And they are slowly disappearing. Ring material falls into Saturn's atmosphere constantly, pulled by the planet's gravity. Scientists estimate the rings will be gone within 100 million years. You are here during the brief window when they exist. That is something. In this story, you are in the rings of Saturn. The ice moves around you. Below you is the planet. Above you is the black of space. And the cold here is the cold of somewhere very far from the sun. Holding very still, waiting. You reach out and touch a piece of ice. It drifts past slowly, close enough to touch. The size of a large suitcase, slightly irregular in shape. The surface of it not smooth but pitted and scratched. The accumulated damage of millions of years of slow collisions with other pieces in the ring. You put your hand against it, and it is cold in the most direct possible way. Not cold like a freezer, cold like something that has never been warm. Cold that goes immediately through the glove you are not wearing and into your fingers as if your skin were not there. The piece of ice does not stop. It continues on its orbit, pulling away from your hand, moving on its slow path around Saturn with the absolute indifference of something that has been doing exactly this for 100 million years and has no interest in your presence. It drifts away. Another piece takes its place in your field of view. then another. The rings are not sparse here. There is always something nearby. Always another piece of ice or rock moving past at a slightly different speed, on a slightly different orbit. The whole system. A slow-motion crowd scene of objects that will never stop moving and never arrive anywhere. You look at the piece that just passed. You can see into it. The ice is not white. Not the white of fresh snow. It is clearer than that. Old ice. Ice that has been ice for 100 million years. And compressed and refrozen and struck by other pieces and by micrometeorites until its crystal structure is dense and clear. In the right light, you could almost see through it. You can see the faint gold of Saturn reflected in its surface as it moves away. The temperature here is negative 180 degrees Celsius, about the same as the dark craters on Mercury, but different in character. The cold of Mercury's shadow craters was the cold of enclosure, of a place hidden from the sun. The cold of Saturn's rings is the cold of openness, of being very far from the sun in a place with nothing to hold any warmth, even if warmth were available. The sun from here is a very bright star, not the overwhelming presence it was on Mercury, just a very bright star, giving light but almost no heat, yet illuminating the ice around you in a way that is sharp and clear and beautiful, and not warm at all. The rings are moving at about 70,000 kilometers per hour around Saturn. You are moving at the same speed. You do not feel this speed. There is nothing to feel it against. When everything around you is moving at the same velocity, the velocity disappears as a sensation. You feel perfectly still. You are the least still you have ever been in your life. The Earth you came from moves around the sun at about 100,000 kilometers per hour, and you never felt that either. Speed is only real when you can measure it against something. You look down at Saturn. You will do this often. You cannot help it. Saturn below you is not something the eye passes over. It is something the eye goes to and stays at. The way eyes go to fires and moving water and other things that the brain classifies as worth watching continuously. The planet is pale gold. Pale cream in some bands, slightly deeper yellow in others, with faint horizontal lines that are the same cloud band system as Jupiter, but quieter, less dramatic, the color more uniform, the whole surface giving the impression of something smoother and calmer than the turbulent bands of its larger neighbor, but the size of it. From here, inside the rings, Saturn is not a circle in the sky. It is a hemisphere. It fills the space below you so completely that your eye cannot take it all in at once. You have to move your gaze across it the way you move your gaze across a landscape. Left edge to right edge, the planet extends further than the comfortable field of vision. It is close enough that you can see texture in the clouds, close enough that the bands are not just lines but structures. Weather systems, the top surfaces of an atmosphere thousands of kilometers deep. You can see your shadow on the rings. Not clearly, not a defined shape, but the sunlight comes from one direction, and you are in it, and the rings below you are slightly darker in the area where your body interrupts the light. A small, imprecise shadow on a 100-million-year-old ring system. You were here. The rings will carry that shadow for as long as you are here to cast it. On the planet below, storms are moving. They are too far away to make out clearly, but the cloud patterns shift as you watch. Saturn's atmosphere is not still. It has jet streams and storms and periodic outbursts where enormous white storm systems erupt from deep in the atmosphere and spread across the planet. None of that is visible from here as drama. From here it looks like a slow, beautiful change in the pattern of pale gold and cream below you. The planet breathing. You find Titan, Saturn's largest moon. You know it by the color. Every other moon visible from here is gray or white, cratered and airless and cold. Titan is orange, a deep, hazy orange, the color coming from the thick nitrogen atmosphere and the complex chemistry happening in it. Titan has weather. Titan has clouds and rain and lakes and rivers. The rain is methane. The lakes are methane. The rivers carved into the ice surface of Titan by flowing methane. But it has them. In the solar system beyond Earth, Titan is one of the very few places where liquids flow across a surface. You look at it for a long time. The orange glow of it. The specific color of a world that has an atmosphere, but the wrong atmosphere. That has weather, but the wrong weather. That has the structures of a living world without the life. Or perhaps with it. You do not know. No one does. The rings of Saturn are silent, not quiet. Silent. There is no atmosphere in the rings, no air, no medium for sound. The pieces of ice move past each other, some of them colliding gently. The impacts, sending tiny vibrations through their surfaces, and none of those vibrations reach you. You can see the collisions. A small piece striking a larger one, a slow impact. The smaller piece bouncing away and spinning off on a new trajectory. You watch it happen and you hear nothing. The silence here is the same silence as Mercury. Total, physical, the silence of vacuum. But the silence feels different here. On Mercury, the silence was the silence of a place exposed and harsh, a place where the sun was enormous and close, and the ground was ancient and hostile. The silence there had an edge to it, and a wrongness that matched everything else about being on a world that was trying to kill you quickly. The silence of Saturn's rings is softer. There is no other word for it. The silence here is the silence of something very far away, and very cold, and very beautiful, and very indifferent. The ice moves. The planet turns below you. The sun burns far away, its light sharp and clean and cold. And in the middle of all this motion, all this slow, vast movement, there is no sound at all. The universe is operating in complete silence, and you are in the middle of it, and the silence is not frightening. It is restful. You let yourself feel that. You are floating in the rings of Saturn in complete silence, and for a moment, despite everything, despite the cold that is already in your hands, and the vacuum that your lungs are doing their best to work around, and the fact that Saturn's gravity is slowly, very slowly, pulling you downward toward the planet below. For a moment, the silence is simply itself. Rest. Silence. Ice moving past in slow patterns. A large piece of ice rotates slowly a few meters above you. It is roughly the shape of a boulder, irregular, perhaps 3 meters across. You can see your reflection in one of its smoother facets, a small dark shape in a bright field of stars. You, in Saturn's rings, reflected back to yourself in 100-million-year-old ice. The reflection is not sharp, more of a suggestion of you, a dark shape that is approximately you, floating in the brightest part of the solar system's most beautiful structure. You drift toward the Cassini division. A gap in the rings, not a small gap. A gap 4,800 kilometers wide, a dark band between the outer A ring and the inner B ring, visible from Earth as a dark line through the ring system. From inside the rings, drifting toward it, the change is gradual and then dramatic. The ice around you thins. The pieces become fewer and further between. The crowded movement of the main ring gives way to something more spacious. Then you are in the gap. It is not empty. The Cassini division is not truly empty. It has material in it, just far less than the main rings, but compared to where you were, it feels empty. The pieces of ice are so sparse that you can see long distances in every direction without anything interrupting the view. You float in the gap and you look. In one direction, the inner edge of the A ring, and a wall of ice and rock that is not actually a wall, but appears to be one from here. The density of the material making it opaque at this angle. A white cliff face, stretching away in both directions, and upward and downward as far as the eye can follow. In the other direction, the outer edge of the B ring, the same. Another white cliff of compressed ring material, equally distant, equally vast. You are between them. In a corridor 4,800 kilometers wide, with a wall of ice on each side, and Saturn below you, and stars above you, and the silence everywhere. The gap exists because of Mimas, a small moon of Saturn only 400 kilometers across, with a crater so large it makes the moon look like it should have been destroyed when it received the impact. Mimas orbits Saturn at a specific distance, and that distance creates a gravitational resonance with the material in the Cassini division, a push-pull that has slowly cleared that region over millions of years. A small moon 400 kilometers across created a gap 4,800 kilometers wide in the most spectacular ring system in the solar system. You float in the gap that a small moon made. You look at the walls of ice on either side. The cold is very complete here. The rings are disappearing. Not now, not in your lifetime, not in 1,000 lifetimes, but on the time scale of the solar system. The rings are temporary. Ring material falls into Saturn constantly, pulled down by the planet's gravity. The rate of loss is significant enough that scientists have calculated the rings will be substantially reduced within 100 million years and may be gone entirely. And you are here during the brief window, the brief 100 million year window. In geological terms, in solar system terms, the rings exist for a moment. You are inside that moment. That is not nothing. That is everything. The cold has been working on you since the first moment. In the rings, there is no heat source. The sun is far enough away that its warmth, never strong at this distance, does not reach you in any meaningful way. The ice around you radiates no heat. The vacuum conducts no heat in either direction. Your body is the only warm thing in your immediate environment, and it has been giving that warmth away to the surrounding space continuously since you woke up here, with nothing returning it. Negative 180 degrees is the temperature of the rings. Your body is 37 degrees. The distance between those numbers is 217 degrees, and your body has been trying to maintain it since the first moment, pushing warmth outward to keep the inside at the right temperature. And it is losing that effort degree by degree. Your hands are the first to go quiet, not painful, not anymore. Past the pain, the hands have been cold long enough that the cold has moved from sensation into state. Your hands are not reporting cold anymore. They are simply cold. The nerves that were telling you this have gone quiet, the way very cold nerves go quiet, which is to say they have stopped operating at the temperature they have been brought to. You look at them. Your hands are floating in front of you. The low gravity of the rings, which is nearly zero, means nothing is pulling them down. They float at the level where you held them, and they will stay there unless you move them. This is the specific strangeness of microgravity. Your hands are exactly where you left them. The ice pieces passing nearby hold their positions too, each one continuing on its orbital path with the precision of something that has been in the same orbit for a very long time. Everything here holds its position. Everything here moves at exactly the speed it has always moved. The rings have been doing this for 100 million years, and they will do it for 100 million more. The ice cycling endlessly around Saturn, the gaps maintained by the resonances of the moons, the whole system in a slow and complex balance. You are the only thing here that is not in balance. You are the only thing here that is using up something it cannot replenish. Your breath is visible. Even in the vacuum, there is enough trace gas near you from your own exhaled breath to see it mist briefly before it disperses into space. Small clouds of water vapor, freezing almost immediately. Tiny ice crystals forming and then drifting away on the orbital mechanics of this place. Your breath is becoming part of the rings. The molecules of water you are breathing out will join the ring material. They will orbit Saturn. For 100 million years or until the rings are gone, some trace of what was inside you will be moving through this place. The rings will carry you even after everything else is finished. You cannot see it from here. But at Saturn's North Pole, There is a storm in the shape of a hexagon, a perfect hexagon, 6 equal sides, each one roughly 14,000 kilometers long, the whole structure rotating in place like a slow geometric machine. It has been there since at least 1981 when the Voyager spacecraft first photographed it, possibly much longer. No one knows exactly why Saturn's atmosphere produces this shape at the pole, when every other planetary atmosphere produces circular or oval storms. The mathematics of fluid dynamics in a rotating system can produce certain patterns, and a hexagon is one of them. But seeing it on a planet is something else entirely. A hexagon made of clouds, rotating steadily at the pole of the second largest planet in the solar system. You think about this. The universe produces geometric perfection without trying, without intention, without anyone designing it or asking for it. The physics of a rotating gas planet creates a 6-sided shape at its pole, simply because that is what the physics produces in those conditions. The same way crystals form in 6-sided shapes. The same way snowflakes are 6-sided. The geometry is in the rules, not in any plan.
You are floating in rings of ice arranged by the same kind of rules. The gap you drifted through was made by orbital resonance. The ice pieces around you are in their specific positions because of the mathematics of gravity and velocity. You are the least mathematical thing here. You are here for no reason that physics requires. You are just here. Cassini, the spacecraft, not the division named after the same astronomer. The Cassini spacecraft spent 13 years orbiting Saturn, from 2004 to 2017. It passed through the rings. It photographed the hexagon at the pole. It flew close to Titan and Enceladus and the other moons. It sent back more information about Saturn and its system than everything that came before it combined. On September 15, 2017, with its fuel nearly exhausted, Cassini was deliberately steered into Saturn's atmosphere. It burned up. Its atoms became part of Saturn. The mission controllers who had worked on the spacecraft for decades watched the signal stop. Some of them cried. The spacecraft they had built had become part of the planet it spent 13 years studying. You can see Enceladus, small and white and very bright, one of the brightest objects in the solar system, because its surface is almost entirely fresh water ice that reflects sunlight almost perfectly. It is small as moons go, about 500 kilometers across. It could fit inside France. But Enceladus has something that makes it extraordinary. It sprays water into space. From the south pole of Enceladus, geysers erupt continuously, sending jets of water vapor and ice particles hundreds of kilometers into space. The material from these geysers feeds one of Saturn's outer rings. Deep beneath the ice surface of Enceladus, scientists believe there is a global ocean of liquid salt water, kept liquid by tidal heating as Saturn's gravity flexes the moon. The water reaches the surface through cracks in the ice and erupts into space. You watch it from here. The geysers are not dramatically visible at this distance, more of a shimmer at the south pole of the moon, a faint suggestion of material being ejected into space. But knowing what it is changes how you look at it. A small moon, covered in ice, with an ocean inside it, spraying liquid water into the vacuum of space around Saturn. That water has the chemicals that life needs. Scientists know this. The Cassini spacecraft flew through the plumes and tasted them. Hydrogen, carbon dioxide, methane, salts, the ingredients, the building blocks. Whether anything has assembled those building blocks into something alive, somewhere in the dark ocean under the ice of Enceladus, is a question that cannot yet be answered. You look at the small, bright moon. You think about the ocean inside it. Warm and dark and full of the right ingredients, very close to where you are dying of cold in the open rings. 2 places, same Saturn system, same orbit around the same sun. In the rings, open vacuum and ice and negative 180 degrees, and nothing alive.
Inside Enceladus, potentially, a warm, saltwater ocean that has been there for billions of years with everything life needs. The universe does not distribute possibility evenly. It puts warmth and water and chemistry in specific places and cold and vacuum in the spaces between. You are in the spaces between. You are looking at a place where the conditions might be different. You are moving toward Saturn. Slowly, very slowly. But Saturn's gravity, which is stronger than Earth's, has been working on you since you arrived. In the rings, you have been in a kind of orbit, moving with the ring material. The orbital velocity keeping you from falling directly toward the planet. But you are not perfectly orbiting. You are not ring material. You do not have the exact velocity needed to maintain a stable orbit at this distance. And slowly, over the hours you have been here, the imprecision of your situation has been accumulating. You are falling. Not the dramatic fall of Jupiter with its clouds and lightning and the feeling of descent through layers of weather. This fall is gentler. You are drifting downward through the ring plane, the ice pieces above you and below you, the planet growing very slowly larger in your view. You watch it grow. The pale gold of Saturn, the faint banding, the rings stretching out from the planet's equator and extending to both sides. From this angle, descending slowly through the ring plane, you can see why Saturn from the outside looks the way it does. The rings are so flat, so thin relative to their width, that from the side they almost disappear. But from here, inside them, they are the entire world. A piece of ice the size of a small car drifts past above you. It has been in the rings for 100 million years. It will be in the rings, in some form, for millions more. You watch it go, slow and patient and entirely at home in this place. Another piece below you, smaller, the size of a melon, perfectly white, also patient, so entirely at home. The rings accept everything that arrives here at the right speed. You did not arrive at the right speed. You are being given back. The rings are thinning around you as you descend toward the inner edge. And the material becomes less dense as you approach Saturn. This is the region where the rings are being lost most quickly, the material falling into the upper atmosphere, becoming part of the planet. You can see the atmosphere below you now clearly, the pale gold layer of cloud, the top of Saturn's weather, closer than it was. The distance between you and the planet is decreasing, not quickly, not dramatically. Saturn does not do things dramatically. Saturn does things slowly and with great patience, and eventually. The first molecules of Saturn's atmosphere reach you before you reach the atmosphere. Trace amounts, the very uppermost edges of the planet's gas, extending slightly into what should be vacuum. The boundary between atmosphere and space, not a sharp line but a gradual transition. The molecules are sparse, far apart, but they are there. You feel them before you can measure them. A faint resistance, a first breath of something that is not vacuum. The something is mostly hydrogen. Saturn's atmosphere, like Jupiter's, is mostly hydrogen and helium. You cannot breathe it. You cannot use it, but it is atmosphere. It is a planet having an outside layer. It is the beginning of the thing that stretches down into Saturn for tens of thousands of kilometers, of the gas getting denser and hotter until it becomes whatever Jupiter and Saturn become in their deep interiors. You are entering that, but you are entering it slowly, and the entry has a quality that Jupiter's did not. Jupiter took you suddenly, swallowed you into its bands and its winds and its scale, almost immediately. Saturn is receiving you. The atmosphere here is thinner at the top, gentler, the entry into the upper cloud layer a gradual immersion rather than a sudden plunge. The temperature is rising. After the extreme cold of the rings, the upper atmosphere of Saturn is almost warm by comparison. Not warm, minus 100 degrees. But after negative 180, the difference is significant.
Your body, which has been in the rings long enough for the cold to reach very deep. It receives the relative warmth of the upper atmosphere, the way it would receive sunshine after a very cold night. Not enough. Never enough. But something. You look back up. The rings are above you now. From below, from inside the atmosphere, the rings are a stripe across the sky. A bright, thin, white stripe running from horizon to horizon. What looked like an entire world from inside now looks like a line. A thin, flat line of ice and rock drawn across the sky of Saturn. Beautiful from here too. Different. Reduced to a line, but beautiful. You were inside that line. You were one of the pieces in it, moving with it, in the rings of Saturn. Now, you are below it, and it is a stripe in the sky, and the two views of the same thing are both true and both real, and neither one is the complete picture. You cannot see the rings the way they should be seen from inside them, while you are outside them. You cannot see them the way they should be seen from outside while you are inside. The full reality of the rings requires a position that does not exist. Every view of Saturn is partial. Every view of anything is partial. You saw the inside. That is the view almost no one has had. The light changes as you go deeper. In the upper atmosphere, the sunlight filtered through the cloud tops gives everything a pale golden quality, clean and bright and cold. As you descend, the light dims. The cloud layers above you are thick enough to scatter and absorb more of the light with each kilometer. The golden tone deepens to amber. The amber deepens to something darker. The wind finds you, Saturn's wind. And in the upper bands, it moves at speeds of around 500 kilometers per hour. You feel it as a push from the side, the specific sideways pressure of a very fast, very dense flow of gas carrying you along the way. Jupiter's jet streams carried you. But this wind is different in feel. Jupiter's wind was powerful and turbulent, full of the energy of the most massive planet in the solar system. Saturn's wind is fast, but somehow more even, more sustained, less violent. You travel with it. Below you, deep in the atmosphere, there may be lightning. The Cassini spacecraft detected radio signals from Saturn that indicate electrical activity deep in the clouds, storms that generate lightning the way Jupiter's storms do. You cannot see them from here. You are not deep enough yet, but you know they are there. In the electrical discharges of a gas giant's weather. The same process happening in the same way in a different planet. The pressure is increasing, slower than Jupiter. Saturn's gravity is slightly less than Jupiter's, and the scale of the pressure increase is different. But it is increasing. The weight of the atmosphere above you is measurable now. Your ears know it. Your lungs know it. You look up one more time. The rings are not visible from this depth. Too much atmosphere between you and them. The sky above you is amber cloud. The same amber as the cloud you came down through. The same pale gold of Saturn's upper atmosphere, seen from within rather than from above. The rings are up there. You cannot see them. They are still moving, still orbiting, still carrying the trace molecules of your breath that drifted into the ring material during the hours you spent in them. In 100 million years, when the rings have thinned and the material has mostly fallen into Saturn, some of what was in you will fall with it. You will become Saturn. You are already becoming Saturn. The light is very dim now, not gone, just dim. The deep amber of an atmosphere, many kilometers thick above you. In the dimness, you can see the clouds around you in detail, not the distant banded patterns of the planet seen from space. The specific texture of actual clouds, the way they move and fold and form and dissolve. Saturn is making weather right now, here, around you. The same weather it has been making for billions of years. Storm systems forming in the upper layers. Rain. And if rain is the right word for what falls inside a gas giant. The constant circulation of a planet that has no surface for weather to land on, and so the weather is simply always in motion, always becoming. The rings are above you.
You cannot see them anymore. But they are there. 100 kilometers above you. 1,000. However far the atmosphere extends between you and the vacuum where the ice moves. They are still moving. Every piece of ice on its orbit. Every gap maintained by the resonances of the moons. The Cassini division between the A ring and B ring. The ice that reflected your shadow when the light crossed you in the right way. The breath you breathed out. Those molecules are still up there. Water ice, frozen from your exhaled breath, drifting with the ring material, too small to see, too numerous to count. Part of the rings now, on their orbital path around Saturn, part of the system for as long as the system lasts. You left something here. Not intentionally. Not as a monument, just the molecules from your lungs. It added to the ice and rock of a ring system 100 million years old. It is a very small addition, smaller than small, but it is real. The pressure is large now. Your body is managing it the way bodies manage large pressures, which is not well, but with a certain automatic commitment. The system's running what they can run for as long as they can run it. You think about the rings. The first thing you saw when you opened your eyes. The ice moving slowly past. The piece that was roughly suitcase-shaped with the pitted surface. The reflection of yourself in the smoother facet of a larger piece. The wall of the B-ring edge in the Cassini division. The stripe of the rings visible from below. A thin, bright line across the amber sky. You saw all of it. The most beautiful structure in the solar system. From the inside, that was yours. The pressure is very large. The amber is very deep. The rings are above you. They are still moving. Close your eyes. The ice was very old. The silence was very complete. Saturn was very beautiful. The rings are still moving. You were here. A note of science. Saturn is the 6th planet from the Sun and the 2nd largest in the solar system. It is the least dense planet with an average density less than that of water. If you could place Saturn in an ocean large enough, it would float. Saturn's rings are made primarily of water ice, with some rock. The individual pieces range from the size of a grain of sand to several meters across with some larger objects. The rings are 300,000 kilometers wide, but only 10 to 100 meters thick in most places. If the rings were shrunk to the same scale as a sheet of paper, the paper would be thicker. The rings are estimated to be between 10 and 100 million years old. They are losing mass constantly as ring material falls into Saturn's atmosphere, pulled by gravity and electromagnetic forces. Scientists estimate the rings will be significantly diminished within 100 million years. The Cassini division, the gap between the A and B rings, is 4,800 kilometers wide. It was created by an orbital resonance with Saturn's moon Mimas. Any particle in the Cassini division would complete exactly 2 orbits for every 1 orbit of Mimas, and the repeated gravitational nudges from Mimas over millions of years cleared the region. Saturn's North Pole has a persistent hexagonal storm system, roughly 30,000 kilometers across. It has been observed since the Voyager flybys in 1980 and 1981, and is still present today. The hexagonal shape arises from the physics of rotating fluids, but seeing such a precise geometric pattern in a planetary atmosphere remains one of the more striking features of the solar system. Enceladus, Saturn's 6th largest moon, sprays water vapor and ice particles from its south pole through a system of cracks called tiger stripes. The Cassini spacecraft flew through these plumes and detected hydrogen, carbon dioxide, methane, and molecular oxygen, along with silica particles that suggest hydrothermal activity on the seafloor of the moon's subsurface ocean. Enceladus is considered one of the best candidates for finding microbial life in the solar system. The Cassini spacecraft, a joint mission of NASA, the European Space Agency, and the Italian Space Agency, orbited Saturn from 2004 to 2017. On September 15, 2017, Cassini was deliberately plunged into Saturn's atmosphere to avoid any possibility of contaminating the moons with Earth microbes. It was destroyed within minutes of entering the atmosphere. The mission returned over 450,000 images and produced hundreds of scientific papers. Next, Uranus.